if you woke up one morning and felt lighter? Not just well-rested, but physically, noticeably lighter. You step on the scale, and it shows you've lost 10% of your body weight overnight. A miracle? Not exactly. It turns out it's not you that's changed. It's the entire world. Gravity just got 10% weaker. At first, this sounds fantastic. Every day becomes a low-gravity wonderland. The world athletic records are not just broken, they are obliterated on the very first day. The new high jump record is now well over 2.5 meters. Basketball games look like they're being played by superheroes, with players hanging in the air for what feels like an eternity before dunking. You can carry all your groceries in one trip, effortlessly. Life seems to have gotten an easy mode update. But this initial euphoria would quickly fade as we start to notice the downsides. The first hint comes when you try to drive your car. You press the brakes at the usual spot, but the car doesn't stop. It skids. With less gravitational force pushing the tires onto the road, there's a significant loss of friction. The number of traffic accidents would skyrocket globally as every driver on the planet has to relearn the new physics of motion. Anything that relies on friction and weight to function is now unreliable. Trains might struggle to grip the rails, and the simple act of walking on a slippery surface becomes a major hazard. But the real problems go far beyond our daily commute. Think about water. Hydroelectric dams, a major source of our planet's electricity, generate power from the immense pressure of water falling. With water now weighing 10% less, the force it exerts is reduced. The output of every hydroelectric dam in the world would drop significantly, triggering a global energy crisis. Rivers would flow with less force, altering their patterns of erosion and sediment deposition, which could lead to ecological chaos over time. But even a power crisis pales in comparison to what would happen to our atmosphere. Earth's gravity is the invisible cage that holds our precious air around the planet. Weaken that cage, and the atmosphere begins to expand. The air pressure at sea level would drop, making it feel like you've permanently moved to a city at a higher altitude. For most people, this would be manageable. But for anyone living in already high-altitude locations, like Denver or Mexico City, the air would become dangerously thin. Climbing Mount Everest would no longer be a monumental challenge. It would be an impossible mission, as the death zone would effectively extend down to much lower elevations. Over the long term, our planet would start losing its atmosphere to space at a much faster rate, bleeding away the very air we need to survive. The planet would start to protest. The immense pressure from gravity is what holds the Earth's tectonic plates in a delicate, grinding balance. A sudden 10% reduction in that pressure would be like taking your foot off a massive geological break. The pent-up stress in the Earth's crust could be released, triggering a worldwide cascade of earthquakes and volcanic eruptions as the planet adjusts to its new gravitational equilibrium. The Earth would groan and shudder as it reshapes itself. And perhaps the most poetic and terrifying consequence would be seen in the night sky. If that pole weakens, the balance is broken. The moon wouldn't fly away instantly, but it would begin a slow, inexorable drift into a higher, more distant orbit. Over millennia, our closest celestial companion would get smaller and smaller in the sky. The tides would weaken, and the nights would grow darker. That comfortable force we take for granted, that 9.8 meters per second squared, isn't just a number. It's the anchor that holds our entire world together. And loosening our grip, even by a tiny fraction, doesn't let us fly. It just makes everything we know begin to drift apart.